Okay. The next experiment what we are studying is two-way and three-way control of lamp. So here how we are verifying this two-way and three-way control of lamp is by the help of truth table. So first I'll write the circuit for a two-way control. So I'll take, this is the neutral part, this is the phase. I'm applying a single phase supply. Once I give the supply, once I apply the supply comes, the charges flow through the phase, and let me take this switch as switch A and this switch as switch B, and the terminals as 1, 1 dash, 2, 2 dash. So I'll take like this the terminals where it has to be connected for two-way control of lamp. Now once I give the supply comes from phase and it comes to switch A. Now I need to verify whether it is operating. How to verify? For verification purpose, I'll write truth table. So this truth table consists of switch A position, switch B position, and lamp status. So there are what is switch A position. Now once I give the supply, let me assume now the switch A position now is at 1. That means it is now is at 1 position. Now switch A is at 1 position and switch B is at 1 dash. Now what happens? The supply comes through A, flows to one position terminal, comes to 1 dash, again comes to switch B and flows towards the lamp, and therefore what happens to the lamp? Lamp glows, it turns on. So the next trial what I'll do, I'll keep the switch A position in 1 position itself. Switch B from 1 dash I'll connect it to 2 dash. Now what happens? Once I give the supply, it comes to A, moves to 1, comes to 1 dash, but there is an open terminal because B switch is connected to 2 dash terminal, therefore here it has become open. So now what happens? The lamp will not glow. In the same way, in the next part, I'll keep switch A to 2 position and switch B to 2 dash position. So A comes to 2, from 2 dash to B. So what happens? It turns on. In the same way, I'll keep this in 2 position, and this I'll change it to 1 dash. So now switch A is at 2. It comes to 2 dash, switch B is now connected to 1 dash, therefore the lamp will not glow because it becomes a open circuit. Now I have formed a truth table. So the same thing I need to verify using the kit that it's been provided for two-way and three-way control of lamp. Okay, so how to do that? So this is the kit arrangement that whatever is there for a two-way control of lamp. So you can see from the supply to the board it has been given. So this part of the switch I'll take it as A switch, and this part of the switch I'll take it as B switch. These are the 1, 2 terminal, 1 dash, 2 dash terminal, whatever I have written in the circuit. So there is a provision for lamp to be connected, so I'll connect the lamp to the provision that has been connected. So now for two-way arrangement, I'll make one external connection. I'll just connect the terminals. Since you can see from switch A to switch B, you can see internally it is not connected. So that means I need to connect the internal term. I need to make switch A and switch B as a through terminal. So I'll give an external connection like this. Okay. So now I will turn on the circuit. Once I turn on, so now the first part with the truth table is switch A is at 1 position. So now the switch A is at 1 position. This is 1 dash, this is 1, this is 2, this is 1 dash, this is 2 dash. Okay. So now switch A is at 1 position. What happens? The supply comes to 1 position, comes to this terminal through the wire. It is coming to this terminal. Now for this switch B should be at 1 dash terminal. So what I do, I keep it as 1 dash. So now what is happening? The supply will come and flows towards the lamp. Therefore, the lamp is glowing. In the same way, I'll keep the switch A at one position itself. I'll change the switch B to 1 dash terminal, 2 dash terminal. Therefore, from A position it comes to this wire. Through this wire it comes to switch B. But switch B is in 2 dash position. Therefore, it becomes open circuit. Therefore, the lamp is not glowing. Now, I'll place switch A at 2 position. From 2 through this wire to 2 dash, lamp gets on, and I'll place it at 1 dash, lamp turns off. So this is how you need to do this experiment, where you need to verify the experiment by the truth table. So if this experiment comes to you in the exam, what do you need to do? You need to write all the procedure part, aim, apparatus and circuit, and you need to write the truth table, trace the path of the current, you need to write the path direction, current direction, then you need to write the status of the lamp. If this is correct, then only we allow you to do the experiment on the board. Okay, so this is two-way control of lamp. So the next part of the experiment is three-way control of lamp. So two-way we have seen earlier. Now three-way control of lamp, that means there will be 3 switches which will be controlling one loading parameter, one lamp. So for three-way control of lamp, this circuit is like this. So I will give a single phase supply. That single phase supply through the phase comes and falls to switch A position. So this switch A has an intermediate, in three-way control, it will be having an intermediate switch, where this intermediate switch will be having 2 types of connection in it. One is straight connection and one more is cross connection. By the angle in which you turn the switch, intermediate switch, it will align itself into straight or cross connection. So now if I give a supply, this also should be verified along with the truth table. So the truth table looks like this: switch A and switch intermediate switch, either it is straight connection or cross connection, switch B and lamp status. Now let me start now. Now I'll give a supply. The supply comes through phase and it hits the switch A. Let me assume that switch A is at one position now. So if switch A is at one position, it comes to P. Now let me tell that intermediate switch has the straight connection. Straight connection means it has to come from P to Q, R to S. If it is cross connection, P to S, R to Q, it is like that. Now I have assumed it as straight connection. So switch A, 1, it is in 1, therefore it comes 1 to P. Straight connection means P to Q. Now I will take switch B at 2 position. So from Q to 2 to the switch B and flows towards the lamp, therefore the lamp turns on. So in the next part, I will place the switch A at 1 position, switch B I will place it at 2 dash position, and it is a straight connection itself. So phase switch A 1 position comes to P, from P to Q it comes, from Q to 2 it will come, but switch B is at 2 position now, 2 dash position now, therefore it becomes an open circuit, therefore the lamp doesn't turn on. Now that is the second case. Third case, 1 dash and switch B is at 2 dash, it turns on. 1 dash to from R and S, 2 dash to B, lamp turns on. So it goes on like that. And now what is cross connection? Cross connection means it is from PS to RQ. So now for that I'll take switch A is at 1 position and switch B is at 2 position and intermediate switch is at cross connection. So phase supply will be given. It comes through phase. It comes to switch A, it is at 1 position, it comes to P. Intermediate switch, now it has been changed to cross. From P to S it will go. From S it goes to 2 dash connection, 2 dash terminal, but switch B is at 2 terminal, therefore it becomes an open circuit, therefore lamp doesn't turn on. So this is how you need to verify using this truth table. So 1 dash, 2 dash is the operating terminals of the switches. Okay, so now this will verify using the hard kit part. So this is a 3-way board, whatever I talked. So this I'll take it as switch A, this I'll take it as switch B, this switch, and this is the intermediate switch, what I am talking about. So if there is in the intermediate switch, as you can see, there are numbers written it as 1 and 2. If this intermediate switch is turned towards one terminal, that means it has a straight connection. That means the charges flow from P to Q, R to S. If the same intermediate switch is connected to number 2 position, then it becomes a cross connection. That means the charges flows from P to S, R to Q. This is how it operates. Okay. So now I'll place the lamp in the provision provided. So now I'll turn on the supply. So once I turn on the supply comes and hits the phase. So the supply comes and hits the phase. From the phase terminal, it is coming to switch A position. So switch A is now in one terminal. Okay. So switch A is now in one terminal. So it comes to P. Now I need to tell what happens to intermediate switch. So I'll tell intermediate switch to be at straight connection. So I place it at number 1. Therefore it becomes a straight connection. So the charges curve flows from P. From P to it goes to 2. But see, switch B is at 2 dash position. Since it is at 2 dash position, the lamp is not turned on. Right? Now what I do, I'll change this switch B position to 2. Now what happens, supply comes to the one terminal, comes to P, from P to Q, Q to 2, 2 to switch B, and it flows towards the lamp. Therefore lamp is turned on. I'll change the switch A terminal to 1 dash. Lamp turns off because it becomes open circuit. Now what I'll do, I'll change the switch B terminal to 2 dash. So the circuit closed and therefore lamps close on. So this is for straight connection. Now I'll change the intermediate switch to cross connection. Now what is happening? The supply comes and hits the 1 dash terminal. From 1 dash terminal it is coming to R because switch A is at 1 dash terminal now. So it is coming to R. Since it is cross connection, from R to Q is what the connection is flowing. So from R to Q it is coming, from Q to 2 position it is going, but switch B is at 2 dash terminal, 2 dash position. Therefore the lamp is not turned on. So if I place this switch to 2 terminal, the lamp will automatically turn on because it is a cross connection. Now I'll place switch A to 1 terminal, lamp turns off. Switch B to 2 dash terminal, lamp turns on. So this is how you need to verify 2-way and 3-way control of lamp using the truth table. Okay. Thank you. So in the remarks you need to write 2-way and 3-way control of the lamp is been verified using truth table.